All right, hi everybody. In this video, we are going to discuss what exactly are Google Colaboratory, Python, and LaTeX. We're going to be using these this semester, and how do they all relate to each other. And so if you are not familiar with any of those terms and you've never done any programming at all, do not worry. That is what my expectation is. So I'm assuming students are not familiar with coding. They've never used Colaboratory before, have no idea what LaTeX is. So if you fall under that description, this is really exciting. You're going to learn some new stuff. You'll learn how to use some new tools. And so the goal of this semester, this is not a Python coding class. So my goal is not to teach everybody how to become expert coders. We're going to focus on learning the content in the class, but we're going to use Python as a tool for exploring those ideas. So hopefully it's going to be a nice, gentle on-ramp into Python, but we're just going to be using Python as a way of exploring linear algebra, and we're not going to be talking about hardcore coding this semester. So hopefully it's just going to give you a little introduction into Python, and if you want to explore things further, at least you've gotten a nice introduction into working with Python in Google Colaboratory. So what is Google Colaboratory? So the document that we are looking at right now is called the Google Colaboratory document. And so this is an open source cloud-based software for working with what are called Jupyter notebooks. And so again, if you are not familiar with any of these terms, do not worry. So a Google Colaboratory is like the cloud version of Jupyter in some sense. So just like Microsoft has Word, Google has a doc application that you can work alongside with Word documents. Google Colaboratory is a nice cloud-based application for working with Jupyter notebooks. And so Jupyter notebooks are places where we can interweave different sorts of media. So we can put in text cells, such as the text we're looking at right now. We can put in code cells, we can add videos, we can link to all sorts of things. So it's just an interactive online laboratory for exploring mathematical ideas. And it's all free, it's all online, so you don't need fancy technology and you don't need to buy anything at all. And so here are some links to some useful resources if you're not familiar with Google Colaboratory. Python is a programming language that has, that's probably one of the most general programming languages. It has applications all over the place, such as computational math, data science, app development, all sorts of things. So Python, like Colab, is free in open source programming languages. There's tons of packages out there that are open source and shared that have really useful scripts that we can use. And it's just learning some coding skills are just skills that tend to be in demand in today's workforce. So it's great for us to gain a little bit of background in coding, or at least get a sense of whether you like coding or not, while we're using it as a tool to explore linear algebra. Okay, and then the last thing I want to just describe, since I've used this term, is LaTeX. So LaTeX is a system for rendering mathematical symbols and formulas nicely. So if you've typed things in a Word document, they have like an equation editor and it can get kind of clunky. But when those of us that are typing mathematical papers, we want to render mathematical we have really complicated formulas. So the way that is kind of the industry standard for typesetting mathematics is LaTeX. And so LaTeX actually has a nice universal applications across many different software applications. Like it can be used in Word and PowerPoint and email, things like this. And the gist of LaTeX is oftentimes we have equations that we would like to type nicely, and LaTeX gives us a nice way of entering mathematical formulas. So for example, the formula that is entered above, in LaTeX, I entered this, and you can kind of look at what I've highlighted in blue and kind of see how that leads to the rendered mathematical formula that you see above. So again, if you're not familiar with any of these things, Colab, Python, or LaTeX, it might seem like a lot to digest at first, but we're going to take some small bites And by the end of this short document, you'll have some exposure and you'll understand what Colab and LaTeX and Python all are. And we're just going to build from there this semester. And as far as LaTeX goes, I just want to refer you to the following document, which I've also put together, which is a quick reference guide for using LaTeX. And so if you click on that link, it's going to open up following Colab notebook that kind of goes through and explains quickly, hopefully, how to use LaTeX and do some of the basics in LaTeX. So it's not a very wordy document. It's more provided with examples for you to see how to do certain things. And then you've got the LaTeX code to tweak and create whatever sort of mathematical notation that you would like to create. And what's super useful before I leave this document is this link over here will take you to a nice cheat sheet of mathematical symbols. So this gives you a sense of what the world of LaTeX looks like. It might look like one of these things that can get, how am I going to learn this? It's a very intuitive system. So hopefully once you get going with it, the learning curve is not too bad. But as you're learning this, I understand that when you're learning new things, it can get a little overwhelming at first. So if you do have any questions about LaTeX, you're always welcome to reach out for me for any help. Okay, so I will end this video here and make a next video that's going to pick up from where we left off, and it's going to talk about really how you can interact with these Colab documents. So we've just been reading the text on screen, but actually all of this text is editable. And so in the next video, I'll just explain the basics of how you can interact with a Colab notebook.